Hello and welcome. In this video, we're going to look at examples of how to use the Ti-83 or the Ti-84 calculator to find the areas under the given normal distribution for intervals of z-scores using the normalcdf function. Our first example says find the area of the shaded region. In another video, if you watched it, you will see that there is a long conversation about how the area under the normal curve is equal to the probability that our x value, our given x value, will be within the region, or within the interval. So basically what we're trying to do with this example is determine what is the probability that for a given sample or population or a given scenario, that if we randomly choose some x value, that it will be to the left of a z-score of negative 0.53. Recall that a z-score just represents the number of standard deviations either above or below the mean. It's a way of standardizing our values. And there's another video or two on the different uses of the z-scores and how to calculate them. I'm going to leave you guys to watch those videos and learn that in a separate segment. But for right now, we're going to focus on using the TI calculator to find the area under the given curve for this region. So we want to find the area to the left of the z-score, negative 0.53. And as I was just talking about, the area under the curve is equal to the probability that our x value is in that region. So in the Ti-84 calculator, there's a distribution button. We're going to use the normal distribution. So we're going to hit second vars to bring up the distribution window. And we're going to choose normalcdf, number 2. Now, if your calculator doesn't have the update and it doesn't quite look like mine, no big deal. Give me a second. Once I'm done entering all these data values in, it'll show also the older display, and I'll talk about that in detail. All right, so as we know from previous lessons, the normal distribution technically extends infinitely in both directions. So it extends to the left towards infinity and it extends to the right towards infinity. In the Ti-83-84 calculator, we're going to need to enter the lower value of the shaded region and the upper value of the shaded region. Well, the lower value is just going to be the left side of the graph. Technically, the left side of the graph is negative infinity. The way that we can enter this into the calculator is negative E99, which is just scientific notation for 10 to the 99th power. So 1 with 99 zeros, some really large number. Now, if you just turn your calculator on, it will probably already say negative 1 E99, but just in case, I'll show you how to do this. Hit the negative button down by the decimal point. Don't use the subtraction button, otherwise you'll get an error. We can press the number 1 and then second comma 99. The second comma brings up the scientific notation. And technically, we don't even really need this negative 1. We just need the negative symbol out in front. Let me show that one more time then. Negative, second, comma, 99. I accidentally hit the comma button twice, so I just deleted it. All right, and the upper value, well, the upper value is the right side of the graph. So the upper value is the given z-score, negative 0.53. So we're going to type in negative 0.53. Since we're talking about the standard normal distribution, we're going to use a mean of 0 and a standard deviation of 1. So we're just going to leave that alone. And if you have the older version of the Ti-83 or 84 and it does not have the update, no big deal. You are just going to type in the lower bound, the upper bound, the mean, and the standard deviation in that order. Your calculator should look identical to mine, and we're going to use the comma button between each of those. That comma button is just above the 7. Press enter, and we will get 0.29805. Now, generally, we're going to round these to 4 place values, so I'm going to round this up, round to 4 place values, unless you're told otherwise. Uh-oh, my stylus does not seem to be working right now. Let's see if I can move my screen a little bit. Round to 4 place values. There we go. All right, so that's one example. Let's look at another example. We want to find the area of the shaded region. Again, the area also means the probability. So we could also say find the probability that our x value is greater than 1.25, which is what the graph shows underneath. So basically, one thing that we need to identify when we're working with these is what is the lower bound, what is the upper bound, and then just type it into the calculator. In this case, the lower bound is 1.25, and again, technically, the upper bound is going to be infinity. So we're going to type in E99 as our upper bound. The mean is still going to be 0, the standard deviation is going to be 1. So again, grab the calculator, second vars, number 2. Now my lower bound I'm going to change to 1.25. My upper bound I'm going to type in E99. Again, this is the scientific notation for 10 to the 99th power, some really large number. We're going to type in second, comma, 99. Again, that's just the calculator's way of doing scientific notation. Mean of 0, standard deviation of 1. And from here, I'm going to just explain this. If you have the older display calculator, no big deal. Let me just make this a little bit bigger so I can actually write this all in here. We're going to do the same thing we did before. The 1.25 is the lower value, comma, E99 is the upper value, comma, the mean, comma, the standard deviation. Again, since we are talking about z-scores, we're talking about standardized values. The mean is always going to be 0, and the standard deviation is going to be 1. From here, we'll press enter, and we'll get that the area to the right of 1.25 is 0.1056. Again, round to 4 place values. Whoops. Round to 4 place values, unless you're told otherwise. All right, let's do a few more examples. These examples ask us to find the proportion of the area under the curve for the following z-scores. To the left of negative 1.85. I always like to visualize these. So my lower bound is going to be negative E99. My upper bound is going to be negative 1.85. Let me clear the screen. Second vars, number 2. Negative second comma 99. Negative 1.85. And I'll get the probability that the z-score is less than negative 1.85 is 0.0322. Then we look at another graph. It says to the left of 1.5. So to the left of 1.5. What I want to notice here is that with the first graph, the purple shaded region was a very small portion of the graph, which makes sense as to why the probability was 0.0322. For the green graph, however, it's going to be a large portion of the graph. So we should make sure that we get a large amount of probability here, or a large amount of the area. My lower bound is going to be negative E99. My upper bound is going to be 1.5. I'm going to show a second way of typing these values in. We can hit second enter, and then we can use the left arrow to manipulate this just a little bit. I'm going to hit delete at the negative button. I'm going to hit delete at the 8. And now I have my lower bound of negative E99, my upper bound of 1.5, my mean of 0, and a standard deviation of 1. I'm just showing multiple different ways of solving the same questions in the TI calculator. So the probability that the z-score is less than 1.5 is 0.9332. Again, when we said earlier, the area of the green shaded region is a very large portion of the graph, which makes sense as to why it's about 93% of the graph. Now the third example here says to find the area to the left of a z-score of 0. Well, this should be pretty straightforward because since the graph is symmetric, the probability should be 0.5. Half the graph is to the left of the mean, half the graph is to the right of the mean. We'll just use the calculator really quickly just to make sure. Again, by pressing second enter, I can just delete a bunch of the stuff here, change the the upper value to 0, and we'll get that it's, oh my goodness, 0.50000000. This is essentially just 0.5. Even if we rounded this to 4 place values, it's 0.5000. There's something else going on here. Remember that this is these technology devices are using integral calculus to get these answers. So there must have been something happening with rounding and really small place values. We don't need to worry about this. This is going to be 0.5. Now the three examples here that show or ask us to find the probability for given z-scores, but these are now asking us to find to the right of some given z-scores. So to the right of negative 1.37, it's approximately there. We want to shade to the right of this. Again, the important thing is to find the lower bound and the upper bound. In this case, the lower bound is negative 1.37. The upper bound is going to be E99. Again, because technically this graph extends to infinity. Second vars, number 2. We're going to put negative 1.37 as our lower bound. We're going to put second, comma, 99 as our upper bound, mean of 0, standard deviation of 1. And this tells us that the probability that our z-score is greater than negative 1.37 is going to be equal to 0.9147. I'm going to skip typing this middle one into the calculator because it's going to be the same thing. Our lower bound is going to be 0. Our upper bound is going to be E99. And the probability will be 0.5 again because it's going to be exactly half the graph. Now our third picture, to the right of 0.67, somewhere around there, shading to the right. What I noticed here is that picture for 6.4a should be more than half the graph. The area for 6.4b is exactly equal to half the graph. And the area for example 6.4c should be less than half the graph. All right, so let's try and talk about this. Greater than 0.67. Again, my lower bound is going to be 0.67. My upper bound is going to be E99. We can hit second. Vars. Number 2 is getting ahead of myself. The lower bound is going to be 0.67. The upper bound is going to be E99. Again, second, comma, 99. Mean of 0, standard deviation of 1. Press enter twice, and we'll get 0.2514. All right, so those are examples of to the left and examples of to the right of given z-scores. Now we've got a few last examples here that ask us to find the area between given z-scores, which are actually going to be even easier. The first graph, or the first example, says to find the area between a z-score of 0 and a z-score of 1.5, which will be approximately here. Well, our lower bound is going to be 0. Our upper bound is going to be 1.5. So we can press second vars, number 2. Lower bound is 0. Upper bound is 1.5. Again, if you're using the Ti-83 or the older version of the Ti-84, lower bound is 0, upper bound is 1.5, mean of 0, standard deviation of 1. And we'll get that the probability that 0 is less than the z-score, which is less than 1.5, is going to be 0.4332. And then we'll do a few more of these. We'll do them rather quickly. Negative 1.25 to 2.0. Second, vars number 2. Negative 1.25 to 2. Enter one more time. The probability is going to be equal to 0.8716. The last two here, if you look, interesting. We know from the empirical rule that between -2 and +2, it is approximately, let me change the color again. Between -2 and +2, it is approximately 95% of the data values. However, using the empirical rule was an approximation. With the normal distribution, we will actually get 0.9545, or about 95.45% of the data values. In reality, the area between -1.96 and +1.96 is even closer to 95% of the data values. 0.9500. All right, so here's how you use the normal CDF in the Ti-83-84 for a bunch of z-score values, again, standard normal distribution values. If you have any questions, please let me know. Otherwise, hope you enjoyed the video, and I'll see you on the next one.